Hello everyone and welcome to our channel Electrical Exclusive.
Today's topic is electrostatics. A charged body either has positive charge or negative charge. And friends, students are always confused with the positive charge because they think the positive charge means excess of protons. The most essential fact is we don't have authority over the protons because we can't extract or add protons to any substance or any atom. And now a question would pop up in our mind that what is actually the positive charge is. The positive charge signifies the deficiency of electron, whereas the negative charge signifies the excess of electron. And now we need to know what is actually the charge. The charge of an electron is 1.6 into 10 to the power minus 19 coulomb. Coulomb is the unit of charge. So friends, you can see this number is really very small. In fact, we can say this value is very much lower than the 1 coulomb charge. In other words, we can say to achieve 1 coulomb charge, we need 625 into 10 to the power 16 number of electrons. So now it is clear the value of the charge is equal to the number of electrons n into the charge of each electron. The value of E is 1.6 into 10 to the power minus 19 coulomb. This is the equation of charge. We know the current is called as the flow of charge. Current I is equal to charge Q per time. Time is in second. If I re-simplify this expression, it would be Q is equal to IT. This is another equation for the charge. When a positively charged body and a negatively charged body connected through a conductor, then current flows. In simple words, we can say we have two charged bodies. This is Q1 and this is Q2. And you can see I have not assigned positive or negative signs here, which means I am not talking about the positive charge and the negative charge. And I have told you Q1 and Q2 both are different, both are not equal, which means one charge will be comparatively positive whereas the other one will be comparatively negative. I have placed these two charged bodies at a distance d from each other. D is in meter. When two differently charged bodies are placed at a distance d in a medium, suppose this is the medium, then the current can't flow between the two charged bodies as we have not connected a conductor between them. But still the electric lines of forces will flow from comparatively positive charge to the comparatively negative charged body, which is known as electrostatics, and this is also called as static electricity. This is the law of electrostatics. Like charges repel each other, whereas the unlike charges attract each other. Suppose we have a medium. We have two charges placed at a distance d from each other. D is in meter. The first one is Q1 and the second one is Q2. And now we shall calculate the force of attraction or repulsion between these two charges. So the force experienced between the two charges will be F directly proportional to the product of the two charges Q1, Q2 divided by the distance square. And the unit will be Newton per meter square. If we re-simplify this expression, it would be F is equal to a constant, that is 1 by 4 pi epsilon 0 epsilon r whole into q1 q2 divided by d square, and the unit will be the same, Newton per meter square. Epsilon 0 refers to permittivity of air or vacuum, and epsilon r is the relative permittivity. The permittivity of the air or vacuum, that is epsilon 0, is 8.854 into 10 to the power minus 12. The relative permittivity epsilon r is equal to epsilon divided by epsilon 0. This epsilon refers to the permittivity of the medium. Now all we need to do is we need to put the value of the relative permittivity in this equation. Force F is equal to 1 by 4 pi epsilon 0. We don't need to put the value of epsilon 0 because it will be cancelled out. Instead of epsilon r, we need to put the value epsilon by epsilon 0. This epsilon 0 and this epsilon 0 will be cancelled out into q1 q2 divided by d square. Still the unit is unchanged, that is Newton per meter square. So the final expression comes out F is equal to 1 by 4 pi epsilon into q1 q2 by d square. The unit is Newton per meter square. This is the mathematical representation of the force experienced between the two charged bodies in a medium. Suppose we have a medium. We have placed a charged particle in this medium. Well, the space surrounding the charged particle will be under stress, and that space is called as electric field. Remember, the electric field is always caused by the electric flux. Electric flux is denoted as psi. It is measured in Coulomb. And the main attribute of the electric flux is it starts from comparatively positive charge towards the comparatively negative charge. And don't forget, like the electric charge, the electric flux is also measured in Coulomb. Well, psi is electric flux. Now we shall calculate electric flux density, which is denoted as beta. The electric flux, that is psi, divided by the area. So the unit will be Coulomb per meter square. This is the equation for the electric flux density. Now we shall find out the electric flux intensity, which is denoted as H star, which is equal to force F divided by the electric flux, that is psi. This is the expression for the electric flux intensity, and the unit will be Newton per Coulomb. And friends, from these two equations you can find the permittivity, which is denoted as epsilon, which is equal to the electric flux density beta divided by the electric flux intensity, that is H star. This is the equation for the permittivity. This is all about the electrostatics.
Stay tuned for more videos and don't forget to subscribe our channel Electrical Exclusive, because we promise to provide you the best we can. Thanks for watching.